All right, class, let's do it. I am recording. We'll see how that goes. It's going to be a long one. A long one for recording, 50 minutes. So hopefully by the time I get back to the office, it'll mostly have compiled the video. Who knows? I've definitely done 15-minute long videos in chunks like that, and it takes a long time for them to actually show up. So I don't know if it'll get posted before I leave or if I'll put it up on Monday, or maybe I'll find out that the microphone isn't working and nothing really happened. So don't know. We'll try. But I just wanted to let you know that I am recording in case, you wanted to state your name and swear or something like that, so that it could live on in posterity forever. Okay, so I put out an announcement. It looks like a lot of people got it because the room is a lot more full, more like weeks 7, 6, 5, 4, 3, 2, 1 instead of the last couple. So I just erased all the code that I had, and it looks like it was old code anyway, because this isn't where I had left the version that I just recently done. But this is something that we are going to try to accomplish. We're going to make some graphics using matplotlib. How many people in here are going to be using Thonny today? And how many people are going to be using CodeHS? Oh, it's actually getting to be a lot more Thonny people than CodeHS. I thought it was the other way around. Let me take care of CodeHS really fast, because in order to get a graphic to show up, it's pretty easy. I still like how in Thonny the windows are much more easy to manipulate, so this is the environment I will work in. So we need to get you guys up and running. Let me go into CodeHS. Haven't been there in a while, so hopefully, yeah, it's me. Okay, so I'm gonna go see if I can find a program that where I have some graphics. Did I put graphics in Fibonacci? I don't think I did. Whoa. Sorry, must have clicked off. Let's see. Let me, this looks like a graphic, simple plot. All right, so if I run this right now, does it have anything to show? No, so it doesn't look like it's running at all. This is the easy way to get a graphic. You go over here in settings, and let me expand this over a little bit. And there's just a toggle switch right here, which is to activate the graphics. We get a new window to pop up. We hit run, and the graphic will show up in here. So you have to play with it a little bit. There is a command that'll get it to fit in the window, which I evidently don't have in there. So that's just a nice, easy way to get a graphic using this CodeHS. All right, so I'm done with CodeHS. So now every time you close up your program and open it back up, you got to toggle that switch back. I think there might have been an option so that when you created the program, it could have been graphic, but I don't play with it enough to remember. All right, now in Thonny, we'll try a few lines of code, and we'll see how many people actually get it to show up. And my guess is not many. All right, so we're going to import matplotlib.pyplot as PLT. And I am going to, well, what you saw in there was a 1d6 distribution. So that just meant I was simulating a die roll using the random class, using specifically randint. So the die roll could have been a 1, a 2, a 3, a 4, a 5, or 6. Do I still have the graphic up? I do. So this was a simulation, and I ran it 6,000 times. So as you would expect, each result would come up about the same amount of times. So each result would come up about 1,000 times. And that's looking like what I got in this result. Now, it is an experiment, and that means that I never expect the bars to be perfectly at 1,000. There's a little bit of comedy here. There's something called theoretical probability and experimental probability. Theoretical probability is the math over the long run, what I would expect, and what was the other one? Experimental probability is what I actually get when I run the experiment. So in theory and practice are the same. In practice, they are different. That's the comedy, okay? So that means that when I run this, I never really expect to get the perfect answer out of an experiment. I can't run it again, but this is what this picture is. So we got a label down here. That's a die face. This is how much is coming up. I got a title, single die distribution. All right. From random, we're going to import rand int. I'm going to do a little bit of review here. When you do your homework in week, let's see, it'll be the last week, so that'll be week 14. When you do that in your lab in week 14, I will be expecting that you use your die class instead of just basically using the functionality of the die class. We built it, it's going to be in our code, so don't skip it. It basically means that all the rand int that you use, all the calls to rand int, they're just actually going to be in a function called roll. All right, so class die and a colon. By the way, this was pretty good on your exams. I'm talking now and not thinking too much. So there. Now, with that pass, if I should run it without thinking, it should be like, okay, that's my constructor. So people did a pretty good job there. Oh, it actually won't pass because I do have one thing missing. That'd be on line 6. Inside the parentheses, what do I always have to have? I got to have self as my first argument, and I will have one other argument, and that will be num sides. Come on, learn to type. And I will give it a default. I'm going to do num underscore sides is equal to 6, because I'm sure that almost every one of you has played a game that has a 6-sided die in it. But if I said how many people play with a 20-sided die or a 10 or an 8 or a 4, then you'd probably say no. You ever play with a 2-sided die? Yes, you have? What is it? Yeah, it's a coin. A 2-sided die is just a coin. So you've probably done 2, 4, 6, 8, 10, 12, 20, 100. I don't know. Does anybody ever play with a 100-sided die? I had a girl bring one into me one day and said, "This is my dad's." You can't touch it. He cherishes his 100-sided die, but she just wanted me to see it. Okay, so 6 is common, so that's why I'm going to make it my default. That means if I pass in no arguments, if I just say my object and then capital DIE parenthesis parenthesis, that means that I've made a 6-sided die because that's my default. All right, now I will say that self.sides is equal to num underscore sides. And that's really all I want to do for a constructor. That's the only thing the die is going to store is how many sides that it has. Again, I said that when I graded maybe 6, 7, or 8 of the 195 exams and looked at all of them at least briefly, and that last question was worth 16 points. That was develop your own class. In general, that was a kind of exam saver for people, and I like that. I mean, you know how to write a class. We did practice that, so that's great. Now we're going to come up with a function called roll. Def roll, pren, put the colon, put the pass, and even though I may not have any parameters, again, if I'm inside of the class, it's not just the constructor. Any methods that I'm going to make, that first argument has got to be self. When you make that call elsewhere outside the class, you never pass self along as an argument, and people did that pretty well. Now, what I'm going to put in for a second argument, I personally am not using today, and maybe I never will, but I'm kind of building in some functionality in case you want it for any of your code. So I'm going to give it another argument, and it'll also be num sides. Now, in this case, num sides isn't going to be the die faces. Oh, wait, num sides is a bad, I want to say bad word, but it's not a swear word. It was just the wrong variable name. What I want to pass in is how many times I want to roll. And that should be something other than num sides. So let's see what I called it in my notes. I called it num rolls instead of num sides. Yeah, it makes sense. Num underscore rolls. Now, I will get a default of 1, and I do know that there's only one N in the fake word num. Okay, so that means that, again, I can make this call. When I make the call, it's got to be a die object that makes the call. So if I make a die called die1, I can't just do roll, I got to do die1.roll. So when I do, if I don't put anything, then I'm going to say that I'm only rolling one time. So I'm going to have an if condition. If num rolls equals 1, then we're just going to return a random int. All right, we're going to return rand int starting at 1, going all the way up to self dot sides. And in this case, it's inclusive. If I did rand range, then I would do the +1. So later on when I do a loop and I'm using a range sort of effect in the loop, I will have a +1. Whereas here I don't, because the built-in function from randint is inclusive on both sides. Now I am going to build a main right now, even though I have more to do in my role, because I just want to get to a spot where we've tested our code. So I'm going to build a main if underscore name underscore equals quote underscore main underscore and quote, put your colon. All right. So we're going to make a object of our die class, and we are just going to test to see if we get a roll, and we can print it. So die underscore 1 is equal to capital DIE, and just parenthesis. So that means this is going to be my default die. Self doesn't get passed in, and I've got a default for number of sides, so this makes a 6-sided die. So die1 is equal to die pren, and let's print out, I want to go roll for now, and this really shouldn't work because roll is a function that belongs to the die class, so I need a die object right here in between that orange parenthesis and the R in roll. So I need that die underscore 1 dot roll pren. All right, so what I expect is to get either a 1, a 2, a 3, a 4, a 5, or a 6, and we'll run it and we'll see if we do. Looks like, well, I don't know what happened there. It looked like an error, but it ended up working. Oh, it just says I have an unused import. Yeah, what import? Yeah, I haven't used matplotlib. Now, mine works. I don't expect most of you Thonny users to work because I'm going to guess that your matplotlib is not in. Okay, so here's what you need to do. You need to go to Tools. You need to go to Manage Packages. In the search for, I don't know what that says, PyPy, you're going to type in matplotlib. You may have to get the spelling exactly right, but you can see it on line 1 quite nicely. And then do a install, and it should take a few seconds, and you should have it. Okay, now if that doesn't work, still go on and try to follow the code, but that really should work. I don't think it should be difficult. That needs to be something you fix. If you can't fix it, switch to CodeHS where it's kind of built in. It's just a little bit more clunky in my opinion. All right, so I already have it installed, so I'll go no further with that. You should be able to hit install, and you should already be done by now. All right, so I only get one result. So what I want to do is put this in a for loop just to test out the function. I already know it works, but this is something you should do. So for maybe trial in range, and range has an E, and we'll do 20 trials. We will print die roll. I don't really want to keep scrolling, so I'm going to do end is equal to, and maybe I'll do a couple of spaces. And now it kind of works like what I said I would do but didn't do, was that give it some functionality for a bunch of rolls. But I just want to see, yep, I get 1s, I get 6s, and I bet I don't find any gaps. Yeah, I see at least a 1, a 2, a 3, a 4, a 5, and a 6. So this does work. I do that for myself too, because sometimes I'm going to forget which one I wanted, randint or rand range. The more I do it, the more I remember, but you know, I've only been doing it for once a year for every couple of years. Okay, so I'm kind of done with this. So I'll go ahead and erase that. That was a trial. I will keep die 1, and it's probably going to live throughout the day. The rest of my code here, well, I'm going to put a comment for you. So this will either return one random number or a list of random numbers. So that's what the num rolls is for. So if num rolls is 1, now I could pass this in as a 1 or nothing, and it would hit that condition because of the default. But if I put in something else, like 20, which I'll have there for a bit, then this should go through what I'm going to type now, which will be my else condition. All right, so this will be the else, and it's going to make a list. So let's say results is equal to an empty list, and then for trial in range 0 through num rolls, we will return a randint. No, we won't. We won't return it. We will append it, but I'll get this here on my clipboard. So we'll take results dot append, and then inside the parentheses, I'll paste randint from 1 to self.size. Don't forget to return it. We do not want to be right here when we type our return, because anytime I return inside of a method or a loop, I am out of that function. So if I expect that I'm going to go through, say in this case 20 times, but I have the return right where my I bar is flashing, it will in fact only go through 1 of the 20 times, hit that return, and I'll get a list with 1 thing in it. Here, I'll make that mistake and accidentally do that. So let's say return results. So last time you saw a bunch of these, 1, 6, etc., no brackets around it. But now, if I say, let's print die underscore 1 dot roll pren, let's pass in, oh, I just made a 20-sided die. That was an accident. I could make a 20-sided die. That wasn't what I wanted to do. I want to put it here and have a 6-sided die with 20 trials, expecting to see a list that goes a fair bit longer than that, but I don't. I only get the 1. It happened to be a 1 just like last time, but I try again and it's a 4, and that's because what I said here is that return is in the wrong spot. We move it back here, and it means that it's not in the loop, it's not in the body of the loop, so the loop will execute its full number of times, in this case 20, and then once it's filled with 20 different ints within the list called results, it returns the entire list. So I'll run that, and now I have a list of results. All right, so I'm done with that. I'm going to make die number 2, and die number 2 will be a, let's say, a 10-sided die, and I will probably use that at some point. And yep, I think I'm done with that page. All right. Anybody need any help getting caught up or need me to pause? Because I go fast if you don't stop me, and this is a day when you need to keep up a little bit. All right, so we are going to begin to make our distribution. All right, so I did this with a, I did this by making a method that returned a list, and then after going through a couple of different graphs, I decided, you know what, it would be a lot easier if I just made it into a dictionary instead. So I am going to go in between my class die and my if name is equal to main, and I'm going to start some functions that are not in class die. So make sure that you're tabbed all the way over to the left. I'm going to define a function. I'm going to call it, this has got a long name. It doesn't have to be that long for you, but you know, when people are not here and they read this code, it'll make more sense if I have a name that's meaningful. So 1 dn underscore distribution. I will have parentheses and I'll say pass. Now, 1dn. Okay, so what I expected when I put up a graphic to begin with, and you saw that graphic that was almost a perfect horizontal of 1d6, the code that I thought I was bringing up was the code I had just worked on, and I was doing a 2d6, and so I expect kind of a pyramid shape out of that. Now, when I did that, that would be a 2d6, 2d6. The 2 stands for how many dice I'm rolling, the d stands for dice, and the number where I've got an n stands for how many sides that they have on them, right? So if you think that that was a name that was just weird, that's just me trying to explain why I chose this, because it's going to be 1 dice, but I could do this for any number of sides. I am not inside of the class die. That means I don't put self as an argument at all, but I will have a couple of arguments. Die is going to be an argument, and num trials is going to be an argument. Now, I could have passed in a list using the functionality of this else statement here, but I figured it would just be easier for people to follow, since dictionary is a little bit hard to list than not to have a list and a dictionary. But inevitably, something like that's going to happen anyway. Okay, but I am going to put a comment for this for people to understand what at least that header's doing, so as I write it, you're a little bit more tuned in. So we're going to be given a die and the number of trials. Number of trials. We are going to make and return a dictionary. Given a die and the number of trials, we make and return a dictionary. Yeah, looks good. Okay. So the reason I pass in die is die knows something that I need to know. That is, like, how many sides do you have? Because I need that to build the dictionary. If I made a list, would I need that? No, not really. I suppose I could do it without a list, so long as I had enough trials and I knew that every side of the die would get hit, but I'll stop rambling now. All right, so the first thing I'm going to do, and this is going to be a comment as well, is I am going to set the keys. So remember that a dictionary is a structure. It uses the curly braces instead of the square braces, and it's a bunch of key value pairs. If I am going to iterate through it, I iterate through it by using the keys. It does have a function that allows you to get the keys. It's dot keys pren pren, and it has a function that allows you to get the values. It's dot values pren pren. So let's see, set the keys. All we're going to do is we're going to ask the die how many sides it has, and in this case, well, let's say we pass in the die that has 6 sides, and we're going to say, all right, go from 1 to your number of sides, and we will have a dictionary ready to go. Let's get that ready to go. Results is equal to a empty dictionary. So we'll say results at, that results at uses the square braces just like a list does. Results at whatever I am scrolling through in my loop, 1, 2, 3, 4, 5, we'll just set it to 0. So that when I'm done with initializing my dictionary, a 6-sided die will have key value pairs of 1:0, 2:0, 3:0, etc., up to 6:0. Same thing if I pass in a 10-sided die, it'll go 1:0 up to 10:0. Once we get this in there, we really should test that and then keep building the function afterwards. So our for loop is going to be for side. That's just a naming convention. It's just a variable, but it's meaningful. For side in range. Now this time, we don't want 0. So we want to give it a beginning argument as well as an ending argument. So if I only give one argument, beginning is default 0. That one argument really is end. If we give 2 arguments, beginning and end. So I want to begin at 1. I want to end at die dot sides plus 1. So here's one of my first examples of this is a range function. And so unlike rand int, which is inclusive on the left and the right, or begin, end, or max min, this is inclusive on the min, but non-inclusive on the end. So that's why I got a plus 1 there. For side in range 1 to die.sides plus 1, we set results at side equal to 0. Well, I can't test it unless I either print it or return it. And since I know returning it's what it's going to do anyway, let's return that result. Return results. All right, let's get this out of the way. It'll come back whenever I run my program. All right, so I have made a die1. Let's have die1 call my function, and let's print it out when we do. So let's print die _1. Okay. Now, when I was doing this afternoon, I did exactly this, and I stopped myself. But I thought, wow, wouldn't it be great if I accidentally made the same mistake? Well, it wasn't an accident, but I've made a mistake. I'll continue. Die1 dot _1dn underscore distribution. I do have a risk of misspelling in this environment. In Zybooks, that thing you use every week, in Zybooks they now have it so it auto completes. That's nice. That's only new as of a year or so ago. But here I don't have it set up so that works. All right, and then I start to pass in stuff. Okay, so I kind of stopped right when I made the mistake. This 1dn distribution function doesn't belong to the die class. Therefore, there's no reason why I should have that die making that call. That's also a reason why I had to pass die in. If this was a function that was inside the die class, it doesn't make sense that it would be, but if it was, then I should be able to get access to the die because it's called implicitly, right? Because the thing that's in front of the call gets carried along implicitly. That's a little bit above our pay grade. Let's just get rid of that. Let's get rid of the dot. We pass in die1, and we'll pass in what I want, number of trials. Well, I'll put in 20, but with a comment that 20 is bogus for now. Because I'm not using that 20, but I have to have it because this has the second parameter. Any int would have done, because nothing in here says I need to do something number of trials because I haven't gotten that far yet. Everybody doing okay? Any questions at this point? No, hanging in there? Cool. All right, so let's run it, make sure I didn't have any problems. Hey, I have a problem. Bogus for now, what? Results. I mistyped something. What line? Line 24. Oh, right there. Anything else? I don't know. Line 30, but that could be other call. There we go. All right, so I got a dictionary. The key 1 has a value 0 all the way over to key 6. Okay, so I built the dictionary. This is, by the way, how I legitimately code, even when I'm not doing something like for teaching, right? So I build a little bit, I test it. I build a little bit, I test it. And if you're going to be somebody that codes, I hope that you do that too. It's a very good practice. All right, so we have built results. By the way, it won't be long before we get graphics. I know that we're more than halfway through the class, but once we got the basics built here, we get one little function that does a graphic. We can cut and paste it, change just a couple of lines out of 10, and we can get a line graph, we can get a bar graph, we can get a different bar graph, all in a matter of seconds. Difficulty there is when I cut and paste, you guys got to stop me if you don't see what I did, because then you'll be like, I don't get that. Okay, so we built the dictionary as far as keys, and now what we're going to do is we are going to use the number of trials, and we are going to randomly make calls to the random.int. We're going to roll. We're just going to roll. So for the number of trials, we're going to roll, and then we'll update the dictionary every time we make a roll. All right. So for, doesn't matter what I call it, but hopefully this won't throw you off. I'll call it trial singular as an individual attempt. For trial in range num trials, we will get a result. This will be singular. Result is equal to die dot roll. Another reason why we want the die to come along for the ride as a parameter so that we can use its functionality within here. Okay, we've used it now twice, die.sides and die.roll. So result is equal to die.roll, and then we can update. I could do this all in one line, and a lot of professors, they'd prefer it that way. I think when we're just learning, it's easier to divide it up. You may be beyond that at this point. All right, so I got the result. It's a random int. So I say results, that's the name of my dictionary, at result. I got stuff to do left, but let me explain. Results is the name of the dictionary. Result is the individual trial that I got on line 26 above. Now that result, let's assume that I'm passing in my D6, is either 1, 2, 3, 4, 5, or 6. So I'm guaranteed to get something that is a key at this point. And so I say, hey dictionary, find that key that I just got randomly, and I want you to set it to whatever you had plus 1. That's really all we got to do. So now we could get that 20 by saying, let's do num trials is equal to 20, and we'll change our 20 to num trials, just so that our code will be reusable in another 2 minutes. All right, so let's see. It builds the dictionary, it populates the dictionary, it returns the dictionary, and this should print the dictionary. Let's see what we get. All right, so it isn't that readable, but we should be able to get something out of it. I had 1s occur twice, 2s occur twice, 3s occur 4 times, 4 occur once, 5 occur 4 times. It looks like it's working. I'm going to add these up: 7, 11, 12, 16, 17, 18, 19, 20. So I did get 20 rolls, and every one of the rolls happened at least one time. And I did get a roll that happened a bunch of times. Now, in reality, does a 6 happen more often than a 1? Anybody want to argue that it does? Does a 6 happen more often than a 1? Why would you argue that?
I'm not arguing that. I'm just saying it's the law of large numbers. Like for a short set of test set, it'll be like whatever. Like maybe it'll go 6, 5 times in a row. But when a test set is just sufficiently large, it'll just roll the same probability.
Yeah, very good. I'm going to repeat, just because the microphone's actually right here, and it probably doesn't pick you up. But you said it's a law of large numbers. Right now, the numbers are not large because the number was 20. But if I turn the number up to 20,000, then I would expect something like the bar graph that I had. I had 6,000, and it looked like it was pretty evenly distributed. And I said, not going to be perfect. Okay. But I mean in real life. You've held a 6-sided die in your hand. Does the 6 come up more often than 1? Have you ever been to Vegas? I want you to shake your head no. Now, has anybody been to Vegas, rolled the dice? I have not. Not even, what are the casinos in Connecticut called? Mohegan Sun, something like that. Ever rolled the dice there? Now, have you ever gotten dice from a casino? Now, this is probably more likely. Is that a yes? What's special about them? They have a hole drilled through them. The hole that's drilled through them is to say, we're done with these, you can have it. But there is something else that's special about them. What is it? The one's huge, right? They drill a large one to balance out the fact that the opposite side has 6 holes drilled out of it versus the one hole. Statistically, people don't see that much of a difference between a million rolls where 6 comes out more than 1, but casinos are really they're really worried about such things. And so if there is the tiniest little margin, they want to make sure that there's not. They also, by the way, have square corners instead of rounded corners, and they figure that plays into their advantage somehow. Moving on. I just got off track. Okay, So now we're going to start to build a actual graphic, and the first one I'm going to build is going to be a line graphic. Let me find it. All right, so I'm going to be right here. Wait a minute, I think I have a return below that. Let me get rid of this. Let me get rid of this. Yep, I did have a return below that. All right, so this is going to give me a graphic. I'm going to call it underscore 1DN. No, plot, sorry. So I'm going to def plot underscore 1DN underscore line, and I will pass in trials. Now, let's see, trials is going to be what? Trials is just going to be the number of times. Oh, no, trials is going to be the dictionary. Okay, so given a dictionary, where am I going to get a dictionary from? I'm going to get it from the distribution. So I'll get the distribution, I'll use the distribution to pass it into a function that's going to make the graphic for me. Given a dictionary, make a line plot. Be sure to always set X label, Y label. I actually don't remember if the B is capitalized. The title. There are a couple other things that you might end up setting when you do these graphs, like maybe you'll make a legend if it gets complicated. Maybe you will make, maybe you'll specify what the tick marks are going to look like. These are things that you could easily look up in order to, if your graph looks weird, to make it look not weird. All right, so let's see. X is equal to a list, parentheses, I'll explain it after I get it, trials dot keys. I'm going to copy and paste this. V is equal to list of trials dot, hey, keys doesn't start with an L. That was a typo. And this will be values. Okay, so when I make a plot, it wants a list of X values and a list of Y values. I didn't have to call this X and this Y. Oops, I haven't called that Y yet. Okay, so how am I going to get that? Well, the trials is a dictionary. It doesn't have lists, but it has a set of keys and it has a set of values. This list function turns keys into a list of keys. It turns values into a list of values, making it more appropriate for what I need it for in order to make the plot. All right, so now I finally am going to use that other import, which is the PLT. So PLT dot plot, inside the parentheses, I'm going to put my X and my Y, and you'd think that would work, and you know what? It doesn't until I do something like this. And I always say, I think this is so strange. I make code that makes graphics, and then I need another function that says, now all the things that I said to show them. Okay, it happens in nearly every language. I suppose there's a good reason for that. But it always feels a little strange for me. All right, I don't have to return anything. This is kind of like a print statement, but it should bring up a pop-up menu. Now, I haven't done what I said I want you to do. That's just because I want to get this to work first. So I don't really want to print this distribution anymore. So I can get rid of the parentheses and the print, and I will say, let's go with data is equal to all that underscore. Got to get rid of that end parenthesis. All right, so I have now gotten the data that I want for my 1DN distribution, and now I will call my plot 1DN line, passing in the data. So the data is going to be the dictionary. I pass that dictionary along to the plot. I'm going to run that, and there we go. So I've got 20 rows. This is a line plot. It's not a bar graph. I know I showed you a bar graph when we began, but this PLT, where is it? Just right here. This makes a line graph. See if I get my graphic back. So I have all the values 1, 2, 3, 4, 5, 6. I actually had 4 not occur one time. That's kind of interesting, but I only did 20 trials. If I did a whole bunch of trials, well, that scale right there could be a little unpredictable. Now, this could have gone all the way up to 20, and I haven't seen it go higher than 7, but let's put in like 6,000 and run it again. Well, I don't get much that looks different, but it goes from like a little less than 960 up to 1040. But here's kind of the strange thing about this is it tries to intelligently build you a graph that fits the window that it has. And so it gives you this little bit of distortion in the outcome. So again, remember that with the bar graph, everything looked almost perfectly even. This is a picture of almost perfectly even. This is just a little bit above 1,000. That's just a little bit below. That's just a little bit below. That's just a little bit above, and a little bit below. So if I turn this into a bar graph, it doesn't look as weird as this looks here. So there's other functions that I put in here. I won't put them in today, where I could light up each of these vertices, or I could even light up the vertices but turn off the lines, and so it becomes like a scatter plot instead of a line plot. But they both use, I believe, the plot function. I'd have to refresh my memory on some of them. All right, now we'll do at least one more, but let's do this so you see examples of it. So let's put in our X label, Y label, and title in between, well, right where I've separated the code here. So let's see, PLT dot X label. It did not have a capital in it. And inside, I put quotes, and it's going to be the die face. Got to end the quotes. I'll copy and paste this. Change the X label to a Y label. We're going to call this frequency. And I want plt.title. And inside of there, something like a 1D6 distribution, 1DN distribution. Looks like I don't have any misspellings. I'll capitalize the D. I'll make the lowercase n. Nah, I won't. All right, let me just see if everything came out. Okay, I do. I have die face. I've got frequency. I've got a title up there. Now, there's one more thing that I'm going to put in, which won't seem like it's necessary at all, but I'll argue why maybe you want it for some things. All right, so let's get in here, PLT dot X ticks, and in parentheses X. Now, when I said X ticks, X is part of the actual function name, like X label, but this X here happens to be my list. So I want the tick marks to just be the values of all the things that were in my list. So now that I have that, I run it, you're not going to see anything different. But my argument is whenever we put in large numbers and that kind of did a like best fit behavior, if you do like X ticks or Y ticks, you're kind of forcing this is where I want my tick marks to be, not where maybe where it thinks it should be. All right, so in case you ever need that, I have a copy of that so you could use that line of code. All right, how you guys doing now with about 7 minutes to go? You still good? Okay, so let's get a bar graph. We'll go ahead and use the 1DN distribution, but let's copy all this so you have an example of a line and a bar. So we'll plot 1DN bar. Just the same, just the same, just the same. Title will be different. No, it won't. X tick's fine. All right, so this is going to change. So this will make a bar graph. We haven't changed the function yet. So we get rid of the word plot and we put in the word bar, I believe. Now, I think this works with X and Y, but I do have a third argument, and sometimes you could have other arguments there, and I got to look up what the name of that argument is. Edge color, no caps. edge color equals, and I did blue. You can use other colors, red, pink, whatever you want. Not every color you could think of, I'm sure, is going to be like a constant in Python. Like, I don't know how many color names there are, hundreds, I suppose. So if you want a list, I know that you can get it. I don't have the function in mind that prints them all out, but all right. So anything else that has to change here? I don't think so. All right, let's test it. So all we have to do, I use the same dictionary, so I don't have to change anything until I get to this line right here, and we change it from line to plot, or line to bar. Let's run it. And that's what the graph looked like when we got here. All right, now I could stop there, but I would like to go a little bit further. Maybe I don't get it done before we leave, and I think this might be, no, I think I have the 2d6 in my code if I'm going to give it to you. So if we don't finish it in the next few minutes, which we probably won't, I'll probably have the final version online. You can take a look at your code versus my code and go, okay, these couple of things. All right, so when I said we could do a 2d6 distribution, it kind of looks like a pyramid. Does that sound right to you? Not every outcome is going to be the same. It's a 2d6 sum. If I have a d6 and a d6, the smallest value I can get is 2. The largest I can get is 12. If you ever played Monopoly, first of all, you've wasted hours of your life, maybe. If you've ever played Monopoly, well, you don't like that. You like Monopoly. So you do. Okay. That's cool. But you know the dice result. So you know what's the most common dice result you can get? The most common sum? It is 7. Did you see his fingers, or you knew that? You knew it? Okay. You don't play with the free parking rule where you get the money, do you? Okay, I'm glad you answered what's that, because that's a way to make the game go on forever, and it's not really in the rule book, but it just seems like one of those Mandela effect things where people just follow that rule when that rule doesn't exist. That means that every time you pay taxes or something, you put that money on free parking, and then when somebody lands there, you get it. You do use that rule, or you just like, I understand that. It makes the game go on a lot longer than it's intended to go on. It is an old game. It's a very long game. I'm sure that if you have fun with it, keep going. I don't want to, make it so that you don't have fun with it. Okay, now, how common are doubles? Don't know? All right. Well, our chart won't say what we would get from doubles, but in order to do this, we need our distribution function. So let's copy this. Let's come down here. Maybe we get this function done. So let's do change the 1 to a 2, and let's put in the word sum in here, a 2dn sum. Now when we do that, we need 2 dice. So we're going to pass in die 1, and we'll pass in die 2, and have a number of trials. Set the keys. Set the keys does change. Whether we have a 6-sided and a 10-sided, the smallest is still 2, because the smallest on any die is 1. Now, what I'm going to add together is die 1 dot sides plus die 2 dot sides plus 1. Okay, so the highest on 2d6, that would be a 6. That would be a 6. So total, I've got a 12. Add 1. That's a total of 13 because I'm using range, which is non-inclusive on the max side. This sets all the keys, and let's see, what else do I need? I need to change results. So result is equal to die 1 dot roll plus die 2 dot roll, pren, and up the results. Now, we could easily get a graph, but probably have seconds left. So let's turn this into a small number again. And instead of plotting, let's see, where is it? Instead of plotting, let's just print out some stuff. So 1dn, we change it to 2dn, put the word sum in here. And now let's print the dictionary. And so I expect I crashed. No, I didn't. But 20 is bogus for now. What? Come on, come on. I didn't pass in something. Line 67. Oh, I didn't pass in die 2. Now, my die 2 is a 10-sided die, and I've only got 20 trials, so let me set this to a die d6. And let's try again. All right, so I get 1, 2. I get 1, 12. Did I get the most 7s? Well, oddly enough, I did with a tie. I got 6s is the most common. The distribution, by the way, is 7 is most common, 6 and 8 are the second most common, then the 5 and the 9, and it just keeps going down to the 2 and the 12 are the least common. All right, that's where we leave it. Next class, at the very least, what I'm going to do is I'm going to make a stacked bar graph, and it'll be like boys and girls randomly chosen for a family, right? Like if you're going to have 4 kids, what's your probability distribution look like across the whatever United States? So it'll be a little bit of an upgrade to our graphics, but we'll also finish that one. All right, I'll see you guys next week.